Bismillahirrahmanirrahim. Thank you so much for watching this video. In this tutorial, we will try to solve some basic problems regarding source-free RC circuits. In the previous lecture, we had studied the basic concept and also formula derivation for the source-free RC circuit. Let's put 2 minutes for the revision. So in the previous lecture, we studied the natural response of the source-free RC circuits. So what is the natural response? The natural response is that suppose we have a capacitor which is already have charging voltage across it. We name that V0, and then we put resistors or any other elements across it. Then how the capacitor will discharge through these resistors, this response is known as the natural response of the circuits. And also we have derived an equation for this purpose. That equation was V of t is equal to V0 e raised to power minus t by tau. So now in this lecture, we will implement this equation to find the natural response of the circuit. So now let's take an example. Let's suppose we have this circuit and we want to find the natural response of the circuit. So how we will get the response? An important point regarding such circuits. In such circuits, we will often encounter the switch, and at this switch is written as t is equal to 0. What does it mean by t is equal to 0? So keep in mind that for such circuit, the switch has three conditions. First is close, second is open. So for the t is equal to 0 or t less than 0, it is close. At t is equal to 0, as this arrow indicate, at t is equal to 0 it will open, and after t is equal to 0 it still remain open. So this equation, this statement or this particular behavior is used to find the initial voltages. This particular behavior is find for the initial condition or initial voltage across the capacitors. So for t less than 0, we will find the voltage V0 across the capacitor, because if we write the equation of the natural response, we have V0 e raised to power minus t by tau. So in this equation, there are two things that are unknown. First is the V0 and the second is the tau, that is equal to RC. So we must calculate these two things to find the natural response of the circuit. So V0 will be calculated for this condition. For t less than 0, we will calculate V0. So let's see how we will calculate the V0. So now let's take the first case. In the first case, for t less than 0, what will be the circuit look like? If I close the t is equal to 0 from the original circuit. For the original circuit, we have t is equal to 0, the switch will be closed. So in this circuit, we have closed the switch, and now our circuit will be look like this. So as you know that we are applying the DC voltages, so the capacitor will be opened for DC voltages, because DC voltage have frequency is equal to 0 Hertz, and if I use the formula of Xc is equal to 1 or 2 pi Fc, this will approaches to infinity. It means for the DC voltages, the capacitor will encounter the very large resistance. So now the final circuit will be consist just only on the resistors, where R1 is equal to 6 ohm, R2 12 ohm, and R3 is equal to 4 ohm. So what is the initial voltages? As I have already stated that for t less than 0, we find V0, that is the initial voltages. So if we found the voltages across these 2 points, it will be equal to V0. So these two resistors are in parallel combination. Now we can solve this using the formula. Let's suppose their equivalent resistance, I name it as RA is equal to R2 R3 divided by R2 plus R3. So 12 into 4 divided by 12 plus 4, it will be equal to 3 ohm. So now the circuit will be reduced. It will look like as this is the R1 6 ohm, voltage source 24 volts and the new counted resistors, that is the 3 ohm. Here are the V0 that will be across the capacitor. So for here we can use voltage divider rule because it is a simple series circuit. Voltage divider rule. So to find the V0, voltage divider rule will be used as this: RA divided by R1 plus RA multiplied by source voltage, that is the 24 volts. So V0 is equal to 3 by 6 plus 3 multiplied by 24, and V0 is equal to 8 volt. So now we have find the initial voltages across the capacitor. The second parameter still remains, that is the tau. So now the next task is to find the time constant. Now we have the second case. The second case is when this switch is opened. So now we will have just only this circuit. So you must keep in mind that time constant is calculated at t is equal to 0. Time constant is calculated as t is equal to 0, while initial voltage V0 is calculated as t less than 0. So you must keep in mind these two important points. So now we have the final circuit which is excluded from the battery. This is the RA and this is 1 by 6 farad capacitor. So we can easily find time constant. T is equal to RC 3 into 1 by 6. T is equal to 1 by 2 second. So now we have find the time constant, that is equal to 1 by 2 seconds. So now we can put it into our original equation, that is V of t is equal to V0 e raised to power minus t by tau. V0 we have already calculated and tau we just calculated as above. So we can put here V of t is equal to 8 e raised to power minus t by 1 by 2, or in other words it is equal to 8 e raised to power minus 2 t volts. This is the natural response of the circuit. So now let's see what is meant by this equation. This equation simply states that a capacitor has initial voltage of 8 volt. Let's suppose we have 8 volt initial voltages. This line indicates the time constants. Suppose we take 5 time constants. So for the first time constant, if we put 1 at here, then it will become 8 e raised to power minus 2. So if you calculate on the calculator e raised to power minus 2 multiply by 8, so you can see that there is only 1.08 volt which will across the capacitor. So we can say that for the first time constants, the capacitor voltage will drop suddenly from 8 volts to 1 volts. So someone can ask from you why there is a rapid discharging. So you can easily say that logically RA is very low resistance, that is equal to 3 ohm. So capacitor will be discharged through resistor very rapidly. So there is a sharp decay of voltages from 8 volt to 1 volt. If this RA has a large resistance, then this response will look like as follows. So it solely depends upon the value of RE. For the changing of RA, there will be the response changing from 8 volts to 1 volt. So in the next circuits we will talk about the source free RL parallel circuits, and we will try to solve the problems of source free RL circuits. Thank you so much.